everyone. Welcome back from your lovely break. Up next, we have Tom talking about scaling a service on a shoestring budget. Tom is a developer, systems architect, DevOps, and security consultant based here in Wellington, New Zealand. I say here because I'm in Wellington as well, so it checks out. His passion is building and helping developers to build solid, robust, and maintainable systems. And I love this part. Tom writes words that control computers to tell other computers to build fake computers that run on different computers. And like this is, Tom spoke about this project at PyConAU 2019. So after his talk this evening, you should go check that out. And I'm really interested to hear more about the details about how this project is scaled and kind of how it's gone over the last year. Tom will be taking questions if we have time at the end, so please feel free to drop them in chat. I'll be collecting them and we'll try to get to them. And with that, take it away, Tom.
Cool. Thank you so much, Oren. It is a pleasure and a privilege to be here today. As she said, I am broadcasting live from Wellington. I was not organized enough to pre-record a talk. So for those of you who don't know me, I'm Tom. I'm a Python developer, systems geek, I guess, and an occasional speaker at PyConAU. I've worn a couple different hats in my day jobs, but nowadays I'm a backend developer and technical lead for Sharesies, an online investment platform founded in Wellington by friends of mine and growing really fast. I've been there since Christmas and it's been a lot of fun. A bunch of my colleagues are attending the conference for the first time. So say hi to them if they're in the chat. They're all super cool people, and I'm really happy that I get to introduce all of you to them. Sharesies on a technical level is a honking big web app built out of Python and Flask and React and C#, and it runs on a pretty hefty AWS setup with a lot of resources, right? You throw a lot of money at AWS sometimes. Today, I'm talking about the other end of the spectrum. Okay, so this is Secator. It's a side project of mine that I've been working on for a little over a year now, properly. It's a site that helps protect users from online harassment and dogpiling on Twitter. If someone is using their followers to harass you on Twitter, you can use Secator to block that person and all of their followers for a set period of time. If you want to learn more about why I built it, check out my talk from PyConAU last year. I go into detail on the idea behind it and on the security considerations that went into building a tool like this. Today, what I'm going to be telling you about is what's been happening since that talk, basically. Okay, so I reset the database when I sort of launched it shortly before PyConAU last year. And the graph that we're looking at now is user signups since I launched the site. It was used by just sort of a handful of friends of mine until I gave my talk at PyConAU. And that's the start of this line because I also reset the database. I don't know if my mouse pointer is going to, oh, I can, yep, my mouse pointer is there. After PyConAU, this little jump happened, and then it just stayed flat for months, right? Secator was sort of invitation only. You could sign up, but you had to get in touch with me before I activated your account. That was my only real protection against it overloading at the time. In February of this year, I removed that requirement and let people sign up and start using the site without asking me permission. That led to this sort of spike here, and it grew to about 60 users. It's still mainly people who knew me personally, though. In May, the New Zealand Python user group very kindly sponsored the server that I'm running Secator on. They asked me what I wanted for help, and I decided to, because I was trying to keep costs down, get a reserved instance. So I bought a reserved instance on a t2.small. I lied in my talk title. A t2.small, figuring that would be fine for my purposes. Anyway, almost immediately after I purchased a fixed set of resources on which I'd be relying to keep the site running, this happened. It changed direction a little bit. Okay. People found the site and they started using it lots. And this was during lockdown. And I suddenly discovered that I have this new routine, which is every couple days I wake up with messages from strangers saying, hey, is the site down? And I note that, in fact, yeah, the site is not just down, but it's a smoking crater after 100 new people tried to use it to block the entire internet each. And so this is Secator. It's my little web app sitting on its tiny little reserved t3.small in Amazon Sydney. It beavers away all day, blocking and unblocking Twitter users on behalf of other Twitter users at a rate of anywhere between 250,000 per day to 2 million per day. And every once in a while, it explodes and dies. And I coax it back to life and try to stop it from blowing up the same way next time. So welcome to my DevOps. So for the rest of my talk, I'm going to tell you about the stuff that I found really interesting while trying to keep this app running on a fixed set of assets as use kind of grew exponentially. And what I'm going to talk about today is going to fall into broadly three categories. I'm going to talk about stuff that I thought was interesting about Postgres, stuff that I thought that was interesting about Celery and asynchronous task management, and stuff that I thought was interesting about user constraints and safeguards. So if you're not really interested in Django or Celery or Postgres or Redis, then there might not be a lot of take-home messages for you, but I'd love for you to stick around anyway, and I'm more than happy to take questions. Not now, I won't see them, but they will be collated, and either after the talk or in the hallway track or all weekend. Come and reach me. Okay, so some technical details. What actually is Secator? I'd draw you a diagram, except A, I cannot draw, and B, I don't think in diagrams anymore. God help me, I think in YAML. I have spent too long as a senior YAML engineer. So what you're looking at is an abridged Docker Compose file. The app itself, the first of those 5 containers, is just the green unicorn HTTP Django app. It does basically nothing. It's just a couple HTML views. All the interesting work happens in the 2 Celery worker containers. That's where pretty much all of the interesting stuff is happening in this app. Postgres and Redis are Postgres and Redis. If you're here, you probably already know what they are. Outside of this Docker Compose file, there's an SSL terminating Nginx server proxying to the app container, and that's the whole thing. It's just running on that instance in Amazon, no RDS, no Elasticache, no Lambdas for workers. Okay, so what Secator actually does is when someone is blocking all the followers of someone who's harassing them on Twitter, it makes a Celery task that retrieves a page of that account's followers. Each page is 5,000 accounts. It spawns 5,000 Celery tasks, one for each account to block. So each Celery task handles one API call to Twitter. And it recursively spawns a task that repeats the process with the next page. Continue until complete. So you've got a loop of a task that does a thing, generates 5,000 tasks, and generates the next task that will generate 5,000 more tasks. When I hit a Twitter rate limit, all of those tasks automatically reschedule themselves according to an exponentially weighted backoff. They all sort of go back onto the queue, and that way all of the tasks kind of get fanned out over time, and they don't fall afoul of Twitter rate limits. Cool. That is the core loop. That's where all the work is happening. There's other stuff that Secator does. It also unblocks people after months or whatever. But this is where all of the interesting load comes from. Okay, so what causes it to explode and die? And actually, there's really just one thing that kills it. And the thing that kills Secator is Amazon EBS disk IOPS burst balance exhaustion. Let's try that again. Faster. Amazon EBS disk IOPS burst balance exhaustion. Cool. Okay. A disk in Amazon, an EBS disk in Amazon, is allowed to do a certain number of reads and writes per second. It doesn't actually matter how big those reads and writes are. It's the number of them per second that you do. And if you do more than that, you eat into your burst balance. And if your burst balance drops to 0, your I/O operations per second get throttled, your disk slows to a crawl, everything jams up. Usually, your system is so slow at this point that you can't even SSH in to stop it. Sometimes you just have to turn the instance off and turn it back on for it to come back online. So this middle line on this graph, that's my IOPS burst balance. You can see a scheduled task that is occasionally expensive. And then you can see, boom. Once this line touches 0, it's over. It's over. It slows the disk down. You can see that there was a bunch of disk I/O here, And then the throttled speed with the load of, this is probably all database stuff, is so high that SSH doesn't even work to go in. That's the end of it. Okay, so what causes the system to have lots of small disk operations? A couple things. But actually, when it comes right down to it, just two things. Too many disk writes by Postgres, and memory swapping to disk as RAM fills up. Those are the two things that cause a huge explosion of disk writes, and it falls over. Okay, so I'm going to talk about Postgres. A good database, and Postgres is a very good database, provides certain guarantees with regard to your data. For example, when you commit a database transaction, that commit is absolutely guaranteed to be flushed to disk when the commit is done. In Secator, every asynchronous task, all of those thousands of Celery tasks, run in their own transaction. And there are thousands of them, tens of thousands of them. Every transaction forces Postgres to force the disk to flush. Too many disk writes, too fast, the disk gets throttled, boom, it explodes. You have to reboot. So on my tiny little instance, I have to tell Postgres that I do not want it to write to disk on every single commit, that I want it to break its own rules. I want it to be more chill about disk writes. I don't need ACID compliance necessarily. Postgres has a lot of parameters that let you tune disk writes, and they're all actually pretty dangerous. There's a bunch of them that you basically just should never use. Partly because they're dangerous, yes, but also because more recent versions have better ways of achieving what you want. So let's start with the correct way of doing this first, so that the primacy effect means that it's the one that's most likely to stick in your brain. What you want to do is look at the Synchronous Commit option in Postgres and its related parameters. What you're basically telling Postgres, if you turn Synchronous Commit off and then set this setting here, the while writer delay, if I can highlight those, to something like 200 milliseconds, for example, you're making the call of saying to Postgres, hey, I know I've committed this database transaction, but to be totally honest with you, if the server crashes, I won't be too sad if I lose the most recent transactions. The advantage of this setting is that your database is still guaranteed to recover to a consistent state in the event of a crash. But you're saying that you can afford to lose the most recent transactions. It's not necessarily 200 milliseconds either, as that documentation says. You could end up losing some number of transactions up to like 3 times that delay, but it'll still recover back. And in my case, when operations in Secator are generally idempotent. So if I fail to record that I blocked someone and then the app just blocks them again, it's not actually that big a deal. The design of my app is such that it's no big loss if I lose the most recent transactions in the event of a hard crash. That's a trade-off that I can make. Don't use these options. They have much more risky issues associated with them. The other really cool thing about asynchronous commit is that you can set it per transaction or per session. So in your non-side project, if you have a database where some transactions are a lot less important than others, you can potentially be a bit more relaxed about some transactions than others. You can say, oh no, this is a maintenance job. It doesn't really matter if it doesn't have to commit immediately at 500 milliseconds or 200 milliseconds or whatever. So that can be really handy in your actual day job projects. But don't take my word for it. Read the documentation. Be careful. If I've got this wrong and if I'm misunderstanding how this works, I won't know until I have an incident where I lose all my data. And then if you've followed my advice, I probably won't warn you because I'll be embittered. I have a few other bits of Postgres advice for you. One of them is to be very aware of what indexes you have and which ones you actually use. Secator's database is now large enough that I can't simply afford for customers to be able to do things that require full table scans. A full table scan would just eat up that disk balance. So having the right indexes for the queries that run is crucial. But also, every index means that there's more disk writes that happen on insert. And quite often, we don't really think about that. We don't have to worry about it too much. But when you're resource constrained, like I am, those writes could actually make a difference. In my situation, it can be a trap. Django creates indexes that you sometimes don't expect and didn't ask for, and they will slow down the writes. So if you're creating a foreign key in Django in your database models, Django always puts an index on that column. They do that so that reverse lookups are always fast in Django, but for foreign keys where you know you don't care about that, be sure to turn those off. It's overhead that you're not using. You might not even realize it's there. My last Postgres tip for today is if you're going to have millions and millions of rows in a table, then don't have a JSON-B column in there. JSON-B is super useful. It's a really cool Postgres feature. But you know what's a huge amount faster and more disk efficient than a JSON-B column? A column. Okay, so I'm going to talk about Celery for a little bit. Celery has not been the cause of all my problems, but all of my problems happen in Celery because that's where all the work is getting done in the app. I'm creating thousands of tasks and tasks that create thousands of tasks, so it adds up fast. I also depend a lot on Celery's delayed task mechanism for scheduling future tasks, that whole exponential back off in the rate limit thing that I mentioned. This is a really handy feature, but it came with overheads that I didn't actually know about at the time and have come back to bite me. So every task waiting to be executed in Secator is sitting somewhere taking up space. It's either sitting in your broker waiting to be delivered, or it's sitting in a Celery worker waiting to be executed. If you're using Redis as your Celery broker, then all of the undelivered tasks are sitting in memory. They're all sitting in RAM. If your task has a delay in it, so that it's scheduled to be executed minutes or hours from now, it doesn't stay in the Celery broker. It doesn't stay in the queue. It gets delivered to the worker, and then it sits in the worker's memory, and the worker holds onto it until it's time to execute it. So once you have too many scheduled tasks taking up memory in the worker, you hit that death spiral, either an out-of-memory killed process or swapping the disk, blowing out your IOPS. Okay, so to keep costs down, as I said earlier in the talk, I'm not using Redis for Postgres, and I'm not using Elasticache. I'm not using RDS for Postgres, and I'm not using Elasticache for the Redis. But I am now using SQS as the Celery task broker. SQS is nice and cheap. It's a lot cheaper than those other two things, which are actually loading up instances that you don't control. And using it means that undelivered tasks are no longer taking up my precious disk I/O or worker memory. It actually didn't turn out to be quite as cost effective as I'd hoped because I'm sending out about 1.5 million SQS messages per day. So it does kind of add up. And it completely solved the problem of my Redis memory footprint growing too large and blowing things up. The Celery memory footprint was still occasionally ballooning out. I have two problems there. One of them is just too many tasks waiting to be executed, especially those delayed tasks that I was telling you about. And then the other one is a persistent memory leak in Celery that just seemed to cause the memory usage to grow forever, no matter what I did. So, as I said, I have a task that creates 5,000 other tasks and then calls itself again to make another 5,000 tasks. It took me way too long to realize that this task was the one that needed to be slowed down. So now that task spawns 5,000 tasks, but then it puts itself on a delay to wait 10 minutes before it runs again. So those bunches of 5,000 tasks kind of get released into the broker, spaced out. That's helped immensely. One change that I finally only made earlier this week was to no longer be doing always one task per block action. Now I can sort of like have one of them be 50, like one task blocks 50 people. And so just multiplying down the number of tasks that have to be sent for work to happen. Stumbled over my words there a little bit. And then there was that memory leak. And I'm not super proud of this, but you see that timeout in the command line? That one right there, can I select it? Yeah. Timeout is a really handy Unix command that simply runs a program for a while and then kills it. So I literally just put a self-destruct in the container. The container dies after 8 hours and Docker Compose restarts it. This is the most traditional memory leak fix of them all. This is your grandfather's computer science. Although, to be honest, I did find a possible culprit. The memory leak seemed to finally go away, or got a lot better at least, when I added these command line options, the without gossip, without mingle, and without heartbeat to the command. I have no clue what any of these three things were doing. I don't know what mingle or heartbeat or gossip are, and turning them off, still doing what I want, so I guess I didn't need them. Okay, so that's all I'm going to talk about Celery. The last section is helping with user constraints. It took me way too long to get around to preventing one single user from being able to overload Secator. You weren't allowed to block someone with an upper bound of followers. You couldn't block someone on Secator who had more than 200,000 followers. But you could happily block a bunch of people who had 190,000 followers each. That became a problem a few months ago when one dude tried to block everybody. The only safeguard I had at the time was disabling someone's account outright, and so I kind of needed something better. It's kind of important to me because I really want anyone to be able to sign up and use this app, but I also really want to make sure that the app always has enough spare capacity so that if someone is genuinely being targeted for harassment, they can use it. And I can't just say, oh no, I'm sorry, the server's really loaded right now. I have been messaged by people at imminent risk of physical harm because of targeted harassment by someone with 500,000 followers. And so I really need the ability to go, yes, this will work for you. Just hit the button and it will at least help you out there. So not long after the dude who tried to block the internet but only managed to block 2.5 million people before my computer died, I finally implemented rate limiting for Secator users. And I settled on a really simple algorithm to implement, this token bucket algorithm. The analogy for a token bucket algorithm is really simple to understand. You have a bucket full of tokens. If you want to block, say, 10,000 people, you have to spend 10,000 tokens. You get new tokens at a steady rate, but if your bucket is full, you don't get any more. So it was a mistake to not have a safeguard like this from the start. And it wasn't actually that hard to add. One of those cool things about the token bucket algorithm is that it actually only requires one piece of state, which is how many tokens you've got. And then the other bits of state are just gravy. You know, I've built this. This is my own account's user profile on Secator, and it just requires 4 bits of state. And that means that I can tune it per user as well. So I can give some users far more resources if they're using the app because there's some urgency about what they're dealing with. Okay, we're pretty much done. I want to finish by talking about the inspiration that comes from constraints. My free time is constrained, and that's why when I chose to build Secator, I built it out of technologies that I already knew. Secator is doing something that helps people. And so there was a time constraint of urgency too. I wanted it launched so that people could benefit from it and not have to wait for me to learn some new technology. The amount that I was willing to spend was constrained. That's why I'm not just scaling out on RDS or a cluster of Kubernetes nodes yet. Those constraints lead to the CPU and RAM things, as you've seen, but haven't I just kind of contradicted myself? I make a decent salary. I could throw money at the problem to some degree. Am I just using my time instead of money? And the answer is, well, yeah, but I like it. You know, liking what you're doing in your off hours is pretty important. I've never really done a programming challenge or a code wars or an advent of code, but I'll spend hours on this weird stuff, tweaking to squeeze a little bit more of efficiency out of it. It's kind of my jam. Working with constrained resources is a famous way to spark creativity. Photographers find more joy when they limit the colors they use. Some of the best movies were made when decisions are born out of resource constraints. When it comes right down to it, my most valuable resource is my attention, and making it fun for me keeps my attention on it. So as my final message, I kind of want to just suggest that if you're not sure what to do next with your project, add some limits on what you can do and work within those constraints. Thank you so much for listening. I hope you have a fantastic conference. I am here to answer questions in the hallway track or on chat or any number of mechanisms. Have a wonderful weekend. Thank you so much.
Thank you so much, Tom. That was really great. And it's really wonderful to see how you've developed this really wonderful and powerful tool and kind of how it's grown over the last year. The spike on your load graph was one of those things that makes me kind of go, ugh. So that was, thank you for sharing that. So we do have probably time for one question because we are at time and we are now going to cut into the break. So we could probably do one question. The chat is demanding the swap question to be answered. So the question that we have is, have you considered using alternates to Celery?
I actually started using something different from Celery because when I first built the project, I was using something called Django Q, which was a really nice, lightweight alternative to Celery. And I recommend you check it out. It was a really handy thing because it didn't require a broker. But I ended up going back to Celery because I had, mainly because of the scheduled task thing. That was a feature that Celery had that Django Q did not. And there was a reason I needed a broker as well in the end, and I can't remember why. But the main one was I needed the delayed tasks, and when I started investigating other asynchronous task workers, I went with Celery because it is the biggest one. It's got the biggest community. I went back to the safe technology that I already know my way around.
Right. That's wonderful. Thank you. We do have one other quick question that we can ask, which is, we've been asked, how can people support you, Tom? What can they do to help you out here?
Secator has a donation page on it, which is just using Ko-fi. I don't even know how you're supposed to pronounce that. I got talked into putting that on the page on February. So if you want to throw a few dollars towards the hosting costs, then that's a very easy way to do it. Otherwise, it's on GitHub, and I don't have much time to develop some of the features that people are kind of looking for. So check out the code on GitHub, have a wee play with it. And if you just want to support the hosting costs, then yeah, just throw a little bit at Ko-fi. Thank you so much.
Cool. Thank you so much, Tom. And with that, we're going into our break. As mentioned, Tom will happily be in chat or in the DevOps hallway track and willing to answer questions. Thank you again so much, Tom. This has been wonderful.
Thank you. Catch you later.